is greater than the sum of its parts. Tennis balls start out as these 85-pound chunks of tree sap. To be specific, refined sap from a rubber tree, aka rubber. There's enough rubber in each chunk to make up to 1,800 tennis balls. And it all begins with constructing the core. The core is the innermost layer of the ball. It's made up of two identical halves cemented together. Workers first load the rubber chunks into this mixer, which churns the rubber while heating it to 220 degrees Fahrenheit. At the same time, this machine, called the auto compounder, prepares a secret recipe of some 13 different chemical powders. These chemicals will make the rubber more elastic and durable. Finally, a worker pours the powders into the same mixer as the rubber. 11 minutes later, the rubber emerges with the consistency of well-chewed bubble gum and drops down onto these giant steel rolling pins to be flattened.
What's the popping sound we're hearing?
That's air bubbles within the rubber. It's popping them as it goes through the rollers.
If an air bubble ends up in a ball's core, it could create a weak spot, causing the ball to tear apart on the court. Once the rollers squeeze out the trapped air, a blade called the slitter cuts the taffy-like rubber into a single ribbon. The ribbon then routes into an extruder, which compresses the band and pops out these rubber pellets. Each pellet weighs just under 1 ounce, the precise amount needed to make 1/2 of a tennis ball core. After the pellets are sprayed with hot water and lubricating solution, they head to one of the factory's most unique machines, the automatic pellet loader. The loader vibrates like a kid's electric football set, moving the pellets around until each falls into a notch. A worker then transfers the tray into a compression press, which applies pressure to each of the 90 rubber pellets and heats them as well. It's a 3-minute process Penn calls the first cure.
How hot does it get inside there?
About 320 degrees.
What does that do to this rubber?
That'll turn it into a liquid.
That liquid soon hardens, and when the press opens, we can finally see tennis balls taking shape. The excess rubber spilling out over the cavities forms a sheet that attaches all the core halves. A die punch machine takes care of the excess by punching out the semi-spheres one sheet at a time.
What happens to all the stuff that's left over?
That gets reused and put into asphalt for the roads.
In this factory, there is a machine for everything. And this one is particularly interesting. It's the I need the cups to all be face down machine. And that's all it's doing, is taking these cups and it's making sure that they're this orientation.
Now that we have the cores right where we want them, it's time to prepare them for assembly. First, a machine called the buff and spray smooths out the edges and coats them with a rubber adhesive. This will help bind the two halves together in the next step, the second cure. Workers load the upper and lower cavities into the press by hand. They use tools called mortar hawks to ensure the core halves are positioned correctly. What happens in the next split second is what makes a tennis ball different from nearly every other ball made today. Just before the top and bottom mold actually make contact, a heat-resistant rubber shroud inside the press seals the chamber. Within seconds, a blast of air raises the internal air pressure to more than 26 pounds per square inch, the exact amount needed to give tennis balls their bounce. When the two halves fuse at 320 degrees Fahrenheit, they seal in that pressurized air. Minutes later, there are 188 pressurized ball cores. But a bare ball core would never do on a court. There's one more layer to add before these balls are game-worthy. And that's the part that makes a tennis ball a tennis ball. Felt.
So why do tennis balls have felt on them?
Well, there's a couple different reasons. One is to protect the rubber core inside the felt.
Okay.
The other is to control the bounce and the flight of the ball as it goes through the air. It causes a drag.
In other words, the fuzzy filaments of felt are like tiny cylinders. The air traveling around the ball surface has to force its way through those cylinders, creating friction and slowing down the ball. The felt also helps a player control the ball's spin and trajectory. As the racket strikes the ball, the fibers in the felt lodge between the strings, which grip the ball long enough to position it during a stroke.
So if I didn't put felt on the ball, like if it was just like a racket ball or something like that, what would happen?
You wouldn't be able to control it. It would hit the ground and just bounce uncontrollably away.
The felt is a blend of 45% wool, 45% nylon, and 10% polyester. Its fluorescent yellow color makes the balls easier to see. After they stretch the felt, a machine called the back coater coats one side with glue. Rollers spread out the glue to ensure uniformity before carrying the felt to the factory's next device, the shone. The shone is a die-cut machine that punches up to 4 layers of felt at a time into shapes called dumbbells. These shapes will cover each tennis ball from top to bottom. The edges will become the visible seams of the ball. The stacks of dumbbells end up here at the edge dip area for another round of glue. Notice the stacks don't dip down into the glue. The vats of glue actually rise up to submerge the stacks. Workers stack the dumbbells so tightly that only the exposed edges get coated. Finally, it's time for this machine to perform one of the most complicated, most precise, most critical tasks in a tennis ball factory. And later, find out what this 75-year-old contraption has to do with SATs. Now that Head Pen has cut the tennis ball felt in shape and coated its edges with glue, it's time for the felt and the core to come together and form a tennis ball. First, this machine dips each core into cement adhesive. Then the cores inch toward one of the factory's most unusual machines, the automated covering machine. Even though it sounds simple, it's anything but. While the cores arrive at one part of the machine, workers load stacks of dumbbell covers into another. Needles strip the individual dumbbells off those stacks and place them into what they call cars. Then a plunger centers and lifts the core into position between these cups. Once in position, the cups wrap 2 felt dumbbells around the ball.
This thing acts almost like a hand, it looks like.
What these are 2 cups that'll come in and place the felt onto the core.
Now that looks like a tennis ball. Next, 2 panels apply pressure and simultaneously roll down the felt on the ball to make sure it sticks. After that, the ball heads back to another press for its 3rd cure. 12 minutes at 325 degrees Fahrenheit, and the felt completely bonds to the core.
After this ball comes out of the 3rd cure, all the fibers of the felt are matted down, so it goes into this machine, the fluffer machine, which is going to give it a steam bath. That steam bath is going to draw out these fibers to increase the aerodynamic drag of this ball so that when it comes out of the can, it has just the right flight characteristics of a new tennis ball.
These tennis balls are ready for game time, except for one celebratory act: printing the logo. A series of lasers uses the ball seams as a reference point to line them up just right. Then a heated plate melts the logo directly onto the ball.